While most of the planet keeps getting warmer, scientists say part of Europe could be heading in the opposite direction. According to a landmark study published in 2026, a massive ocean current system that has kept northern Europe far warmer than its latitude would otherwise allow is weakening, and once it crosses a certain threshold, researchers say it will almost certainly never recover. Some models suggest winters in London could see cold extremes approaching negative 20 degrees Celsius. In Oslo, negative 48. This isn't science fiction. It's a real, actively studied climate mechanism called the AMOC, and it's already measurably slower than it was before industrialization began. Today, we're breaking down exactly what the AMOC is, why it's weakening, what the science actually says about the risk of collapse, and what that would mean for hundreds of millions of people. No guessing, no dramatizing, just the facts, the science, and the real stakes. The Atlantic Meridional Overturning Circulation, AMOC for short, is a massive system of ocean currents that functions essentially like a conveyor belt, pulling warm, salty water from the tropics and the southern hemisphere northward through the Atlantic toward northern Europe. As that warm water travels north and releases heat into the atmosphere along the way, it cools, becomes denser, and sinks deep into the ocean near Greenland and the Nordic seas, then flows back south at depth, completing the cycle. This constant northward transport of warm water is a major reason northern Europe enjoys a noticeably milder climate than other regions at similar latitudes. London sits roughly at the same latitude as parts of Canada that experience far harsher winters, and the AMOC is a primary reason for that difference. Direct, continuous measurements of the AMOC strength only began in 2004 through an observation network called RAPID, but scientists have used indirect evidence, ocean sediment records, temperature proxies, and climate models to reconstruct its behavior over a much longer timescale. That longer record shows the AMOC has weakened measurably since industrialization began, and multiple research teams have spent the past several years trying to determine whether that weakening trend could eventually cross a tipping point into full or near complete shutdown. The 2026 study that changed the conversation. A study published in 2026 in the journal Communications, Earth, and Environment, led by researchers including Nyen, Villeit, Wunderling, Ganapolsky, and Rockstrom, delivered what climate scientists are describing as one of the most significant findings yet on this question. The research concluded that if the AMOC does collapse, it will almost certainly not recover as long as atmospheric carbon dioxide remains above 350 parts per million. Current atmospherics. CO2 levels sit at approximately 425 parts per million and continue rising. According to the study, this means the atmospheric conditions required for AMOC recovery, if collapse were to occur, have already been surpassed, a genuinely significant claim, since it suggests the reversibility of a future collapse isn't simply a matter of future emissions reductions alone. It's important to be precise about what current science does and doesn't establish here. The AMOC is still running today, weakened and measurably slower than its pre-industrial state, but functioning. What remains a genuinely live, actively debated question among climate scientists is exactly when, or under what specific conditions, it might cross a tipping point into collapse, with credible estimates ranging from within the next few decades to potentially not happening at all within a time frame relevant to current generations, depending on future emissions trajectories. What collapse would actually look like for Europe? Multiple research teams have modeled what an AMOC collapse or severe weakening would mean, specifically for European temperatures, and the findings are strikingly consistent across different approaches. Research published in Geophysical Research Letters used the Community Earth System model to simulate an AMOC tipping event, combined with ongoing human-caused climate change, rather than looking at ocean current changes in isolation. That research found that in an intermediate emission scenario, 1 out of every 10 winters in London could see cold extremes approaching negative 20 degrees Celsius, while winter extremes in Oslo could plummet to around negative 48 degrees Celsius, genuinely severe, Arctic-level cold for a city that currently experiences a temperate maritime climate. A separate study examined a scenario where the AMOC weakened by 80%, while the planet's average temperature sat roughly 2 degrees Celsius above pre-industrial levels, essentially testing whether continued global warming could offset the cooling effect of a badly weakened AMOC. The researchers found that even in that considerably hotter world, Europe would still experience what they described as substantial cooling, with sea ice spreading into Scandinavia, the Netherlands, and parts of the northern United States, an outcome that would be further amplified by increased sunlight reflecting off the newly expanded snow and ice cover. Stefan Rahmstorf, a professor of physics of the oceans at Potsdam University who was not involved in that research, described the study's regional modeling as far better resolved than what was possible decades earlier, confirming what he called the long-standing concern that AMOC collapse would have massive impacts on European temperature extremes specifically. Why this would happen? even as the planet warms overall. This is the part of the story that trips people up, and it's worth explaining clearly because on the surface it sounds contradictory. How can global warming cause parts of Europe to get colder? The answer comes down to the specific mechanism the AMOC provides. Northern Europe's mild climate isn't primarily a product of its latitude, it's substantially a product of that continuous transport of warm water and heat from the tropics. If that transport system shuts down or weakens dramatically, Northern Europe loses access to that heat source, even as the planets average out. Global temperature continues climbing overall. The result isn't a contradiction, it's two separate effects happening simultaneously. Global average warming, continuing due to greenhouse gas accumulation, while one specific region loses a major regional heating mechanism it has relied on for thousands of years. Beyond temperature alone, researchers have also flagged significant disruption to rainfall patterns as a consequence of AMOC weakening or collapse, including a documented risk of drastic changes to precipitation in the Amazon, illustrating that the AMOC's influence extends well beyond the North Atlantic region alone, connecting to rainfall systems across the globe through complex, interlinked ocean and atmospheric circulation patterns. Separate research from the University of Copenhagen, published in Science Advances, examined how the AMOC has behaved during past periods of instability, specifically studying how volcanic eruptions during previous ice ages may have triggered sudden climate swings by disrupting the circulation. Professor Marcus Jochum of the Niels Bohr Institute, the study's senior author, explained that the AMOC appears to be considerably more sensitive to external disturbances, such as volcanic eruptions, than scientists previously understood, especially once the system is already sitting close to a tipping point. That sensitivity matters for understanding modern risk as well. Today's primary destabilizing factor isn't volcanic activity, it's the large-scale influx of fresh water into the North Atlantic from melting Greenland ice and increased Arctic precipitation, since fresh water is less dense than salty water and interferes with the sinking process that drives the AMOC's circulation in the first place. Researchers describe this as the same basic vulnerability, a system near its tipping threshold becoming increasingly sensitive to whatever disruption happens to arrive. Why? Scientists still disagree on timing. It's worth being direct about the genuine uncertainty that remains here, rather than presenting a single, settled timeline. A widely discussed 2023 study, led by Peter Ditlevson of the Niels Bohr Institute, estimated the AMOC could collapse anywhere between 2025 and 2095, a genuinely wide range that reflects how difficult the system is to predict with precision, using only around 2 decades of direct measurement data. Ditlevson described the stakes in stark terms, noting the AMOC has not shut down in roughly 12,000 years, and that a shutdown now would represent an extremely large, historically unprecedented change to the modern climate system. Not every climate scientist agrees on the certainty or timing of these projections, and a 2026 review study noted that while evidence supporting the AMOC's capacity for this kind of dramatic, self-reinforcing collapse has broadened in recent years, exactly when, or whether, a tipping point gets crossed under continued warming remains a genuinely active area of scientific research rather than a settled conclusion. Climate researchers continue monitoring the AMOC's strength through the Rapid Observation Array and related monitoring systems, watching specifically for signs of continued weakening or any acceleration toward the kind of tipping threshold described in recent modeling. The Potsdam Institute for Climate Impact Research and multiple partner institutions continue refining projections for both the timing of potential AMOC collapse and its cascading effects on other climate systems, including its documented interaction with Southern Ocean carbon absorption. Given the wide range of scientific estimates for when a tipping point might be reached, this remains a slow-developing story that researchers expect to keep refining as additional decades of direct measurement data accumulate alongside improving climate models. There's a genuine irony at the center of this story that makes it worth understanding clearly, rather than dismissing as an exaggeration. The same warming planet driving heat waves, wildfires, and extreme weather events we've covered repeatedly on this channel, from Japan to Spain to the southern United States, could simultaneously be pushing part of Europe toward conditions colder than anything the region has experienced in thousands of years. That's not a contradiction in the science. It's a demonstration of how interconnected and, in places, counterintuitive Earth's climate system actually is. The AMOC has quietly regulated Northern Europe's climate for millennia, largely unnoticed by the hundreds of millions of people who've benefited from it. Whether it continues doing so for centuries to come, or crosses a threshold scientists say may already be effectively permanent once triggered, remains one of the genuinely open, actively studied questions in climate science today. We'll keep tracking this story and every other major seismic, volcanic, and extreme weather event happening around the world right now. Subscribe if you want to see the next update. Drop a comment and tell me, had you heard of the AMOC before today? See you in the next one.